While we are all joining this event from our own location, we would like to acknowledge that we are meeting on the lands of the Wurundjeri people and the Boon Wurrung people of the Southeast Kulin Nation. We would like to pay our respects to their elders, past, present and emerging, and to all First Nations communities joining us today. Welcome everyone, either from Australia or overseas, to another night at the Observatory. Tonight's stream is in recognition of the International Day of Women and Girls in Science, which was yesterday, being the 11th of February. I'd like to begin the segment by introducing you all to our panellists who will be presenting this evening. Please join me, Jackie.
Hello everyone.
Vicky. Jamie. Saskia.
Hello.
Gail. Ella. And Natasha.
Hello.
And of course, myself, Petra. I will be your host for this evening. As you all can see, tonight is an all-women's panel because at MBO, we have enough women members to accomplish this. That being said, we still have our fabulous male and female outreach crew working hard behind the scenes and on Facebook and YouTube, leading up to and during our streams. And now, here's some information about MBO.
Mount Bennett Observatory is a community-run astronomical society in the Dandenong Ranges. We are completely volunteer-run and have over 500 members. We focus on community engagement, outreach, diversity, and helping our members to get the most out of their love of space and astronomy. The observatory was originally built by Monash University for students to do astronomical research, especially on variable stars whose brightness changes over time. Over the next 2 decades, the site was expanded and upgraded, but eventually took a back seat to modern giant internet-connected observatories around the world. In 2011, our 5 founding members reached an agreement with the landowners and took over the lease and established the society. Now, we run over 80 events each year, including members' nights, public viewings, and special events. We have several special interest groups including deep sky observing, radio astronomy, astrophotography, astro arts, and young observers. In 2020, we expanded our online presence and now host regular live streaming events. We welcome all new members and love making new friends with other astronomy lovers. You will be joining a friendly community of passionate, hard-working amateurs who have a grand vision for the future of the observatory. We hope to see you up at MBO soon.
It is now my pleasure to introduce our first presentation. And first up is Saskia and Vicky. The presentation will include the importance of women, girls, and diversity in astronomy, along with major discoveries, Indigenous astronomy, and social aspects.
Hello and welcome. Thank you for the introduction. And thank you everyone for joining me today, and a special warm welcome to our first time viewers. This is actually my first time as a live stream presenter, and I am just super excited to bring you this presentation. I absolutely love being part of the MBO family, and one of the best aspects is that you get to work with the most amazing people. Vicky Mironova is one of these amazing people, and Vicky has actually put together this presentation that you're seeing, including designing some of the images. Vicky also researched some of the astronomers, so a special thank you to Vicky. I really hope you enjoy the presentation and are super excited as I am, so let's get to it. In this presentation tonight, I'll take you through what we can learn from Indigenous astronomy. I'll talk about the accomplishments made by women in the various astronomy fields, and I'll tell you about the social changes navigated by women of science. I'll talk about the importance of diversity, and finally, the unique culture of MBO. The First Nations communities of Aboriginal and Torres Strait Islanders are truly the first astronomers, with knowledge going back 60,000 years. Now, if you're anything like me and you struggle to visualize constellations, try Indigenous astronomy as a different approach. Constellations are weaved into oral traditions, and this brings the night sky alive. Learning about Indigenous astronomy also honours and acknowledges our First Nations people and the connection between the land and the sky. Traditional constellations such as Orion can be hard to relate to as they are upside down in the southern sky. The Wiradjuri Aboriginal traditions from central New South Wales, for example, depict their creation ancestor, Byami, as nearly the same shape as Orion. Byami is actually upside down as they are tripping and falling just as the constellation sets over the horizon. Next time you want to spot Orion in the southern sky, see if you can spot Byami instead. Have a look at the links at the end of the presentation to learn the full story involving the Pleiades and Byami. Also, check out star lore and constellations of the Burrung people in Lake Tyrrell of northern western Victoria and the Kamilaroi people of the northern part of New South Wales on Stellarium, and this is a free software download. Now, let's jump forward several hundred years and to the other side of the globe and look at the women behind some of the most interesting and influential discoveries that shaped the world. Maria Kunitz was a 17th century theoretical astronomer who challenged the likes of Kepler by reimagining Kepler's equations. Kepler's publication of the Rudolphine tables was designed to assist in finding the position of any known planet in the solar system. What Maria realized that it was far easier if you viewed the planet's position as a function of time rather than the eccentric abnormality. Maria was also a great science communicator and way ahead of her time, and chose to use both German and Latin in science subjects, and this made knowledge more accessible than just to the science community. Now, back to present time. One overlooked person is Professor Li Shuhua. Shuhua was a leading astronomer in the 1950s, greatly improving precision and observational methods used to calculate time. In just a few short years, Shuhua improved quartz clock time computation methods, and this meant that China is now known worldwide for its accuracy, and this has led to the popularization of a single time zone across China. But Professor Li wasn't finished, and in 1973 proposed a new way of measuring time. VBLI is Very Long Baseline Interferometry, and this utilizes radio telescopes to observe the position of distant quasars. From this data, time is calculated. This revolutionary method has improved accuracy of measurements from 10 milliarcseconds to an amazing 0.1 to 0.2 milliarcseconds. It is also the foundation for much geological research, particularly that involving tectonic plate movements. Now, talking about time, let's go back a bit. I want to acknowledge some female astronomers that changed society for the better and whose impact is still felt today. Jean Dumy is best known as the author of Conversations on Copernicus's Opinion on the Movement of the Earth, published in 1680. This book challenged so many religious and social beliefs at the time and inspired many women in the field. Jean's detailed discussion on Copernicus's idea of heliocentrism not only took the science community by storm, but supported the strongest belief that between the brain of a woman and that of a man, there is no difference. Going forward to the early 18th century, Louise du Pierry became the first female professor at Sorbonne University in Paris. In another first, Louise started an astronomy course for ladies, despite her colleagues' fears that the subject matter was too difficult for the female mind. Alongside her teaching career, Louise published many papers on the topics of light refraction, calculations on the movement of the moon and its ellipses, and finally a table on the length of the day and night, which became widely used in civil jobs and perpetuated growth in many industries. Now, I want to talk about the impacts astronomy and culture can have in society today. Lisa Cooley, director of Astro 3D, researched diversity in 2019 and said that the positives of diversity include introducing new perspectives and ideas, increasing productivity and profits, and fostering a culture where there is a sense of collectiveness. Of course, diverse organizations are far more likely to succeed economically. There are simple, effective ways everyone can make a difference for inclusion, such as put the person rather than their sexuality or gender identity first. Remove emotion and judgment from language. Ask for guidance and seek information. Focus on accessibility, not disability. And think first how your statement will make the other group or person feel. More information on diversity is included at the end of the presentation. MBO's vision is for its space to be accessible and welcoming to all, no matter what your age, gender identity, ethnicity, knowledge, background, ability, or language group is. In our short history, we have built a new dome in 2016 for easy access for those with limited mobility. We have welcomed members and speakers from all cultural and linguistic backgrounds. I myself have learnt basic Auslan or sign language as I am passionate about making sure that everyone is included. We embrace neurodiverse and transgender members and people of all gender identities. And we have welcomed a member who is a wheelchair user during the first members' night after lockdown. As an organisation, if you see or hear anything that makes you uncomfortable, please talk to us. There will be no judgment and we will investigate. We will listen and you will have our support. More information is at the end of the presentation. Now, summing up the culture of MBO, I think that we're a bunch of passionate nerds whose love of science and astronomy breaks down all barriers. Now, I really wish I had time to talk further, but I've actually stolen a couple of minutes from another presentation, and I do need to wrap up. But before I do need to give a shout out to two of my favourite astronomers, astrophysicist Kirsten Banks and Professor Lisa Harvey-Smith. Check out Kirsten's passionate and energetic videos on Twitter, and please support Lisa as the inaugural Women in STEM ambassador. That's not bad for someone who was homeschooled from the age of 11, as their school did not accommodate their sexual identity. Now here's the links that I promised you on Indigenous astronomy and inclusion, gender identity and diversity. So I do hope you've enjoyed the presentation tonight, and I do hope that you can look at some of these links. Now, thank you all for listening, and I really hope that you can support MBO and the work you do, and I hope you feel inspired. Thank you again, and enjoy the rest of the show.
Thank you for that, Saskia and Vicky. It is wonderful to learn about the diversity and importance of women and girls in astronomy. And now for a short news break.
After substantial delays, SpaceX successfully launched their second Starship test vehicle, SN9. Performing flawlessly again, it flew to 10 kilometers before successfully executing the belly flop maneuver and free-falling back to the ground. In the previous test, low fuel pressure caused the failure of an engine to fire. This issue seems to have been resolved, but one engine failed to restart for another unknown reason. Going forward, SpaceX has indicated they will use all 3 engines for redundancy upon landing in the future. If all goes to plan, the next prototype, SN10, will launch this month.
Don't forget, if you have any questions about tonight, drop them into the comments and we'll attempt to answer them. There is also a Planisphere giveaway for the question of the night. Our next presenter will be Jackie, and she'll be telling us about women and their contribution to astronomy in the late 20th century.
Okay, thanks, Petra. Okay, so women have always been involved in astronomy, as Saskia has shown us, and quite a lot's been written about women who have made waves prior to World War II. We haven't quite caught up with some of those names from the last 70 years who've changed the way we see the universe around us as well. So tonight I'd like to present a few of them to you, some of whom are Australian and some who have close connections to Australia. And the first one I'd like to share is Ruby Payne-Scott. And she should be in all our Australian astronomy history books. She was one of the very first radio astronomers. She started off as a physicist who started work at the CSIRO in 1941. And at the end of World War II, she set up a radio interferometer on the cliffs of the south head of Sydney Harbour. There's nothing left there today, but there is a park and you can go along and there's a little memorial of the work that was done there and the other people who were working with her. And what they did was they bounced radio waves off the ocean surface to measure the radio waves coming back from the sun and sunspots, and they also made measurements of the Milky Way. And the paper they wrote from their work and describing the techniques they used to do the measurements is one of the most quoted papers in radio astronomy. She was forced to leave work when she became pregnant, because in those days, as some of the older people in the audience might remember, when women got married and they were in the public service, they had to leave. And she tried to hide her marriage, but she couldn't hide it once she got pregnant. And so she was forced to leave, and that was the end of her research. It was very sad for such a brilliant lady. The next woman astronomer I'd like to introduce is Margaret Burbidge, and she was the principal author on a groundbreaking paper that explained how stars created the elements inside them. Now, we're all quite familiar with that now. We know how the iron in our blood and the gold in our jewellery is created inside stars. But it was Margaret here with her husband Geoffrey and 2 other men named William Fowler and Fred Hoyle, who coined the name the Big Bang. The 4 of them did the work that discovered that. However, it was only William Fowler that won the 1983 Nobel Prize for the discovery. And not even he could work out why the Burbages weren't nominated for it. Margaret also held the record for the discovery of the furthest object in the known universe at one point, a quasar. She held the director of the Greenwich Observatory in London for 2 years, but she still had to share the post with the Astronomer Royal Martin Ryle at the time. And she developed the faint object spectrograph that was launched with the Hubble Space Telescope. And this discovered the giant galaxy inside M87, which we're now all familiar with because it has been the first black hole imaged. She only died last year at the age of 100. So she's had a huge impact on the astronomy that we know today. Vera Rubin worked with Margaret Burbage at one stage, and she tried to stay away from controversy when she started. She thought she'd try the nice, safe topic of galactic rotation. But she soon found out that the galaxies were spinning so fast that they should fly apart. And the outer parts were spinning just as fast as the inner parts. Now, this would only be possible if they had much more mass than was clearly visible. And how much? Well, 5 to 10 times as much. That's a huge amount. So over time, her results were confirmed. And astronomers ever since have been looking for the missing dark matter in the universe. Jocelyn Bell Burnell was Australian born, and she's famous for discovering the first radio pulsar. She's also famous for not winning a Nobel Prize for it. That went to her supervisor because his name was first on the paper that was written about it. Now, again, some older members might recognise the graphical figure on the left. You might need to invert it into the negative with white lines and a black background, and they might recognise it as a very famous musical album cover. So I'll leave that up. Maybe the people will put it in the comments if they recognise which one it is. So here is science crossing over into art. Now, here's one, a lady which I recognise very few people might know, but she actually has an award named after her. Now, she's an Australian amateur astronomer who was accepted into the Professional Astronomical Society of Australia, along with her husband Arthur, for their work in flare stars, a type of variable stars that flare up very suddenly. And there was a big campaign to study them in the 1960s. Now, she died towards the end of the 1960s at a young age, and an award was named after her, and it's given to an amateur astronomer who's made a significant contribution to astronomical research in Australia. It's only men that's won it. And that's mainly because only men get nominated. So there's still plenty of room out there for women to win it. They've just got to be nominated and come forward out there. So there's a lady who was very busy in her time. And so girls, women, if you're out there, get into the research. There is so much to be done and so much to be found. Now, Priscilla Fairfield Bock was an American, but she has an Australian connection. She was married to the Dutch astronomer Bart Bock, and this pair came to Mount Stromlo Observatory at Canberra, and Bart Bock was a director at Mount Stromlo for 9 years. They set up the graduate astronomy program there, and they also laid the foundations for Siding Springs a little bit further north. Now, Priscilla was a great science communicator, and each year the Australian National University awards a Priscilla Fairfield Bock Prize to the best female third-year science student. Caroline Porco is a bit more contemporary, and you may have heard of her because she was very involved with the Cassini mission to Saturn, and she was also involved with the Voyager missions as well. So she was the principal on the imaging team for Cassini. So all those fantastic images you've seen of Saturn that poured down from Saturn for 14 years while Cassini orbited it, she was supervising and overseeing all of them. And she's considered one of the most influential people in space today. And lastly, this lady, Caroline Shoemaker, was an accidental astronomer. Now, she was married to a very famous space-related person, Gene Shoemaker. Now, he had a very illustrious career. He worked out the Barringer asteroid crater in Arizona. It was actually a crater and not volcanic. He taught the Apollo astronauts how to prospect on the moon, and he pushed for research into asteroids in space. Caroline wasn't really interested in all that. She was a school teacher, but when she was 51, she'd found her children had left home, and she was at a loose end. And somehow she got interested in astronomy at last. So Gene got her involved with surveying the sky for asteroids and comets as potential hazards to Earth. And at one point, she actually held the record for the most comets found by a person. She's most famously associated with comet Shoemaker-Levy 9 in 1994. So that's the big, long string on the top right. And this comet was torn apart as it encountered Jupiter. And just over a year later, it returned to Jupiter and slammed into it one by one. And the dark scars that splashed over the top of Jupiter's clouds remained visible for months. And it was a big wake-up call around the world. Astronomers, once they knew what to look for, they found crater strings on bodies all around the world, all around the solar system, including on the moon. And this showed it wasn't an isolated incident. So lots of robotic surveys were set up. And so now when you see a comet name, it's often got some sort of made up sort of name like Pan Stars or something like that from the surveys, because it was from all the surveys that were set up because people realised that we were in a lot more threat than we thought we were. It also inspired two major movies that came out around the same time together. So Deep Impact, that tried to be quite true to the science, and the rather less than realistic Armageddon, which is nevertheless still entertaining. And they had a very strong connection to Australia, both Gene and Caroline, because they spent many years travelling through the arid outback, studying craters and impact sites there. Camping out for weeks at a time in very remote areas. And that continued on until Gene was unfortunately killed in an accident on the Tanami track. It's a couple of decades ago. So there are, of course, many more women than this involved in astronomy. This is a bit of a start. But I hope you can see that out of the 8 I've presented here tonight, there's doesn't matter whatever your age or your background, astronomy can still lead you in surprising directions.
Thank you, Jackie. It's wonderful to learn of so many women having had or taking part in astronomy in the 20th century. We now have Ella telling us about Halley's Comet.
Good evening, everyone. My name is Ella, and this evening I'll be taking you on a space journey all about Halley's Comet. Halley's Comet, who is also known as 1P Halley, is arguably the most famous comet there's ever been. The letter P indicates that Halley is a periodic comet. For those who don't know, this means that it occurs or appears at intervals to Earth's vicinity at about every 75 to 76 years. Making it possible for a human to see it more than once in his or her lifetime. The last time she was here was in 1986 and is projected for a return in 2061. Halley was named after English astronomer Edmund Halley, who examined reports of a comet approaching Earth in 1531, 1607, and 1682. Using Isaac Newton's theories of gravitation and planetary motions to compute the orbits of several comets, he concluded that these three comets were actually the same comet returning over and over again, and predicted that she would return in 1758. Unfortunately, Edmund Halley didn't live to see the comet return, as he died in 1742, but his discovery led to the comet being named after him. The comet has since been connected to ancient observations going back more than 2,000 years. Its most famous appearance was in 1066 AD, when it was seen right before the Battle of Hastings. Halley's dimensions are about 15 kilometers by 8 kilometers. In comparison, that's bigger than Los Angeles. It is one of the darkest or least reflective objects in our solar system, and it has an albedo of 0.0, which in simple terms means that it only reflects 3% of the light that falls onto it. Comet Halley has an interesting orbit. Halley moves backward opposite to Earth's motion, and around the Sun in a plane tilted 18 degrees to that of the Earth's orbit. Halley's backward, or in other words, retrograde motion, is unusual compared to other short-period comets, as its greatest distance from the Sun is beyond the orbit of Neptune. Halley's orbit period is on average 76 Earth years. This data corresponds to an orbital circumference around the Sun of about 12.2 billion kilometers. However, 76 Earth years isn't set in stone, as this period varies from time to time because of the changing gravitational effects of the other planets in the solar system. Her appearance has been known to be as short as 74.42 years, which occurred in 1835 to 1910, and has been reported to take as long as 79.25 years, which occurred in the years 451 to 530. With each orbit around the Sun, a comet the size of Halley is destined to lose an estimated 1 to 3 meters of material from the surface of its nucleus. So the nucleus is up at the left-hand corner. Thus, as a comet ages, Halley will eventually dim in appearance and may lose all its ices in its nucleus. From there, the tails disappear, and the comet finally evolves into a dark mass of rocky material, and even in some cases, dissipates into dust. Our amazing scientists have calculated that an average periodic comet lives to complete about 1,000 trips around the Sun. Halley has been in its present orbit for at least 16,000 years. But thankfully, it has shown no obvious signs of aging in her recorded appearances. The comet's pass in 1910 was particularly spectacular, as it recorded that Halley flew by about 22.4 million kilometers from Earth. And to put that into spectrum, that is about 1/15 the distance between Earth and the Sun. And on that occasion, Halley's comet was for the first time captured on camera. When Halley's comet came by Earth in 1986, a lot of developments went underway, and for the first time ever, we could send a spacecraft up to look at it. Several spacecrafts successfully made the journey to the comet. This fleet of spaceships is sometimes dubbed the Halley Armada. 2 joint Soviet-French probes, Vega 1 and 2, flew nearby, with one of them capturing pictures of the heart or nucleus of the comet for the first time. The European Space Agency, Giotto, got even closer to the nucleus, beaming back spectacular images to Earth. Japan also sent 2 probes of its own, Sakigake and Suisei, that also obtained information on Halley. Sadly, the astronauts aboard Challenger's STS-51L mission were also scheduled to look at the comet, but they never got the chance. As many of you listening here tonight may know, the shuttle exploded about 2 minutes after launch on January 28, 1986, due to a rocket malfunction, killing all 7 astronauts. When Halley's sweeps by on Earth in 2061, the comet will be on the same side of the Sun as Earth, and will be much brighter than it was seen in 1986. It will be many decades until Halley gets close to Earth again, but in the meantime, you can see its remnants every year. The Orionid meteor shower, which is spawned by Halley's fragments, occurs annually in October. Halley's also produced a shower made, called the Eta Aquarius. So that sadly wraps up my 5-minute talk today. If you'd like to know more about Halley's Comet, go check her out on the Google search engine, or I recommend NASA, or check your questions in the comment section below, and I can try and go over them with our little Q&A session later on. So thank you for listening and have an amazing rest of the night.
Thank you, Ella, for all that informative information about Halley's Comet. I hope to be around to see when it next passes Earth. It's news break time.
University of Sydney PhD student Yan Ming Wang has developed a new method to find some of the missing matter in the universe. Astronomers have observed that 95% of the mass in the universe is missing. This is believed to be dark energy and dark matter, but even half of the remaining 5% of normal matter cannot be found. Wang used the Australian Square Kilometre Array Pathfinder telescope to observe distant galaxies in radio wavelengths and observed scintillations, hinting at the existence of a cold, dark, diffuse stream of particles through which the light passed. This technique could open up a new window onto vast clouds of cold, dark matter.
Please keep your questions coming. Drop them into the comments and we'll attempt to answer them. Remember, there is a planisphere to give away for the question of the night. Now I have Gail, one of our newest members, joining me for an interview.
Hey everyone.
Welcome, Gail.
Thank you.
Lovely to have you here.
Lovely to be here. Thank you.
Excellent. Okay, so my first question to you tonight is, how long have you been stargazing? And for what? Sorry, yes, go.
Sorry.
No, I was just going to ask you, how long have you been stargazing for, and what area of astronomy are you interested in the most and why?
So I've only been stargazing since probably about March last year, so I'm very new to it. And my main interest is with astrophotography. So I just find the concept of science and art together is just really interesting to me. So my main focus is to learn more about that, which is also why I joined MBO.
Fantastic. Now, what kind of telescope would you recommend to use, or do you use a beginner stargazer telescope?
Yeah, sure. So that's a really common question. And I'll show you a picture of the telescope that I do use. So this one is a Saxon telescope. So it's perfect for if you're just wanting to start out in astronomy and spark your interest in looking up the stars. You can see a lot of detail on the moon. You can see the craters in so much detail. You can see the rings of Saturn. You can see the famous bands around Jupiter. And you can even see some of the polar caps on Mars when it is closer to Earth. So if you're a beginner and you're looking to buy a telescope, I would definitely recommend something like this. It only costs me about $300 and it will definitely spark your interest and you will be wanting to upgrade your equipment really soon.
Oh, fabulous. And what kind of photos have you taken, and any tips for a beginner?
Yeah, sure. So the kind of photos that I have taken with my telescope is what I'll show you now. So these are the type of photos that you can expect to take with a beginner telescope. I haven't used any fancy camera. It's literally just with an iPhone. And it only took about couple months to teach myself how to take these type of photos. You can see that when you take photos of the moon, you can also take them in different phases. So every phase will be a complete unique photo. It's quite a process, and behind those photos is quite a lot of other photos that didn't quite make it. But it's it will really spark your interest when you start taking, especially your first photo. It's definitely very memorable, and yeah, you'll be hooked. So that's it for that.
Fabulous. Thank you. Now, where is your favourite place to stargaze, and what have you done to further enhance your interest in astronomy?
So my favourite place at the moment to stargaze is in East Gippsland, a place near Lakes Entrance. So I find that the skies are really clear there. It's unlike Melbourne, it's very polluted and not so clear. So I do like to get out in the country to do my stargazing. And what I've done to enhance my hobby for stargazing is I have joined MBO, which is awesome. So I know Neil is an astrophotographer, and I'm really excited to speak to him about all his talents and pick his brain about everything. But I'm sure MBO will become my favourite place to stargaze. So I'm very excited.
I'm excited too. Thank you for tonight, Gail. It's been a pleasure sharing your insights with us.
Thank you.
Thank you. Okay, next we have Nikki's presentation about the lunar phases. Nikki made this presentation several years ago on her mobile phone while being a secondary school student and as well as a young observer at MBO. This presentation was an entry into the Eureka Prizes. Enjoy.
Hello, my name is Nikki Yusutov and I love all things space. You get to join me in a 29.5-day journey of discovery of Earth's natural satellite, the Moon. We all know that the Moon travels around the globe, and as it orbits the Earth, we see a spectacular display as the Moon transitions through its different phases. To further explore, let's talk more about the first quarter moon. The first quarter moon phase occurs with the sun being here and the Earth being here. The moon is in a 90-degree angle with the sun and the Earth being situated here. From the Earth, we see half the moon phase being illuminated. This week, you get to join me in the Victorian high country, away from the city's light pollution. This is one of the best places to view the full moon in all its glory. Time to settle in with a nice hot chocolate and wait for the heavens to put on a show. I'll now demonstrate when a full moon occurs. Do not forget, this is not to scale. When the sun, Earth, and the moon are in a line with the Earth in the centre, the moon face is fully illuminated by the sun. Today, here we are at my school. The school environment is the perfect place to learn about what you are interested in. The current moon phase is the third quarter moon, meaning the sun is here, the Earth is here, and the moon is here. It is basically the same as the first quarter moon, as when the moon was over here. From Earth, we see half the moon face illuminated, meaning we see this from down on Earth. So drag out that dusty old telescope out of your teacher's staff room and get out there and view the moon for yourself. Here I am at the Mount Spineth Observatory with the new moon upon us. The new moon is when the moon is at its darkest, as the sunlight does not hit the side we see from Earth. The moon phase happens when the sun, moon, and the Earth are in a line, with the moon in the middle. If you are like me and enjoy things outside of our planet, you should join a club or an organisation and spend time with other like-minded individuals. Now it's your turn to explore the cosmos.
I definitely enjoyed her show, and I'm sure that it will inspire tonight's younger audience. Stay tuned now for our final news break.
Currently orbiting the Earth in the International Space Station is a boomerang. The boomerang was commissioned by the South Australian Museum as an expression of modern Aboriginal culture and ingenuity and was carved by Ghana man Jack Buckskin. It was carried to space on the NASA SpaceX Crew 1 mission. At the end of the mission and upon its return to Earth, it will be displayed in the museum to inspire people to remember that exploration has a long and deep history with the earliest human culture.
Okay, now I have Jamie and Jackie joining me for a roundtable conversation about Pleiades. Hello, ladies. Come on in. Okay, so hello. I have some questions to ask you about Pleiades. So, what are Pleiades, and or as some of them may know them, the Seven Sisters?
Well, the Pleiades is a cluster of stars. Scientists estimate it to be between 75 and 150 million years old. So in astronomical terms, this is actually young to middle-aged, believe it or not. There's over 1,000 stars in the cluster as well, and there's heaps of stories associated with it as well. And some of the oldest of these can be as old as 100,000 years. So it's been around in human history for quite a while.
Okay, wow. And are there any stories about Pleiades?
Yeah, the common one that most people know is well associated with the alternative name, the Seven Sisters, about how there were 7 sisters and one disappeared. But even with that, they're just associated with women or sisters. They're being chased. They might be chased by men. In North America, it can be bears chasing them. Interestingly, some of the Australian Aborigines have the same tale, that they're women and they're being chased by men because the men want to get closer to them. And so knowing that the Aborigines were here, at least 50,000 years ago, the story has to be at least that old. And there's a paper released recently which indicates it may be up to 100,000 years old. And that puts it to when people were dispersing out of Africa. And that points to maybe that's why it's the same tale about the 7 sisters being chased is found in both Europe and across Asia, North America, and down in Australia. But interestingly, it's not in the Pacific. They actually have a different story. Yeah.
Okay, thank you. So we know that there are tales and folklore about Pleiades, but did anyone actually look up to the sky and see them as indicators?
Oh, yeah, the Pleiades was used heaps in the past. The Northern Hemisphere, people in the Northern Hemisphere used to use them as a seasonal marker, so they knew when to sow crops and when to harvest them as well. Going further back again, the Aztec used them as well. The heliacal rising, so when the Pleiades rose at the same time as the sun, that was the starting point for the Aztec New Year. And then the ancient Greeks as well was part of Ptolemy's 48 constellations. And yeah, it was a very, very common story in ancient Greece as well, seeing as the Pleiades were the daughters of Atlas and Cleon from Greece as well. So, and the Pleiades was actually included as part of the Taurus constellation when the 88 modern constellations were drawn up back in 1922, which is pretty cool.
Yeah, it is. So, Jackie, I have this question for you. You said that they're seen as the 7 sisters running away from Orion. Is that right? And are they actually moving the stars?
Yeah, the stars actually are moving together. So they're a true cluster. So they're all moving together in the same direction, but not necessarily away from Orion. That's just the way the story is told. So Orion is seen as a giant man, and they're, the cluster of the Pleiades or the Seven Sisters represents women running away from him. Yeah, it's sort of seen that way in a metaphorical way.
Okay, thank you. And here is a picture of Pleiades. As we can see, it has a beautiful blue glow. Can you tell me why?
Yeah, so there's actually a whole lot of dust surrounding the Pleiades at the moment. But this dust is not the original dust that the stars emerge from. This is actually some dust that is passing by. And when starlight reflects off dust, it has this characteristic blue colour. So when you see the pinky colour, that's very likely hydrogen. Hydrogen has this very signature fluorescent pink colour. This bright blue colour is what we call a reflection nebula, so we can tell that the light is reflecting off all the dust that's in the vicinity of the stars.
It's so beautiful.
It is, yeah.
Yeah, it's so beautiful. Are they famous for anything else?
Where do I start, Petra? So as we said before, the Pleiades are also called the Seven Sisters, but a lot of people can actually only see 5 or 6 without using a telescope or a pair of binoculars. But you can, if you've got good enough eyesight and you're in the right spot, you can actually see up to 14 stars in the cluster without using a telescope or binoculars, which is pretty cool. And I've mentioned this one in a previous live stream as well, so some of you put down in the comments if you remember me saying this. You might actually recognize the constellation in, or the cluster in, the badge of Subaru cars. So Subaru is actually the Japanese name for the Pleiades, and it means coming together, which makes a lot of sense. So anyone who knows their car companies will know this, but Subaru was actually the merger of 5 different car companies. So it makes a lot of sense.
Yeah, sort of for some space facts out there, the Pleiades is the 4th closest cluster to Earth. The stars that make up the Big Dipper and Ursa Major are actually the closest cluster. Then we've got the Hyades that make up the V face of Taurus the Bull. Then there's a fainter cluster called Molot 111, which represents the hair in Coma Berenices, which is towards the north for us in winter. And then so the Pleiades is the 4th closest cluster, around about 440 light years away to us. And going back to how other people see them, in New Zealand, they're not seen as women. They're still represented as a cluster. So across the Pacific, the Pleiades are very important as marking the new year. And it varies from location in across the Pacific as to when the new year starts. So in New Zealand, the Maori take it on the last quarter moon in June. They have a lunar calendar, and it varies a bit between June and July. And we're looking at the Nebra sky disk here from bronze time. So you can see the cluster sort of top right. But in New Zealand, Jacinda Ardern promised to make it what they call Matariki, the national holiday. So the first one's going to be held on the 24th of June next year. But if, say, you go to Hawaii, you'll find that their new year is in a different month. I think it's May. And they call the Pleiades Makaliki, which means the eyes of royalty. Whereas down in New Zealand, the Pleiades represent the eyes of the god. So they're kind of they're children. If you go a bit deeper into it, they're children of 2 sky gods. So the Pacific Islanders have a different myth associated with the Pleiades.
Oh, that's
Yeah.
like wow. That's like wow. Yeah. So I have one last question, and my question is: if I want to find Pleiades in the night sky, where should I look?
So the Pleiades is actually pretty easy to find. So you can find it using the constellation of Taurus the Bull. So the easiest way to do this is to find the constellation of Orion and then follow his belt, and you keep on that line while keeping to, sorry. So keep following that line up. So you can see on the screen there, so you find the belt of Orion, follow it down. The next bright star you'll come across is Aldebaran, circled right in the middle of the screen there. And then follow that line along, and then you'll find the Pleiades. So you should be able to see a group of stars without binoculars or a telescope, and that's how you know you found them.
Oh, thank you for that, Jamie and Jackie, for joining me at this round table and for sharing all that information about those really beautiful stars. And finally, thank you. And finally, we have Natasha explaining why do stars shine.
Why do stars shine? If you ask the question, what is a star? You'll often hear answers like exploding ball of gas, or burning ball of hydrogen, or glowing ball of plasma. But what does that mean? What's a plasma, and what does it mean to say that a star burns? Now, typically, when we think about the process of burning, we're thinking about combustion, the type of burning you see on a campfire, which converts fuel like wood with oxygen to give off things like heat and carbon dioxide. This is a chemical reaction. But when we talk about burning in a star, we're talking about a different type of reaction. Instead of a chemical reaction, in a star, we have nuclear reactions. To understand nuclear reactions, we need to understand a little about what matter is made of. Now, matter is made up of atoms, which we can think of as tiny marbles composed of three types of subatomic particle: protons, neutrons, and electrons. Now, each of these can have an electric charge. Protons are positively charged, electrons are negative, and neutrons have no charge, they're electrically neutral. Now, charged particles are acted on by the electromagnetic force. And the way this force works is that opposite charges attract, like protons and electrons, whereas like charges repel, so two protons which have the same charge will repel each other. In an atom, the protons and neutrons sit in the center of the atom, which we call the nucleus. This is surrounded by electrons, which we think of as orbiting outside the nucleus in a sort of cloud. So, because the nucleus is positively charged and the electrons are negatively charged, the electrons are held in the atom by the electromagnetic attraction. But within the nucleus itself, we have protons close together, which are all positively charged, so these should repel each other. So how does the nucleus stay together? The answer is, there's another force at work called the strong force. The strong nuclear force attracts protons and neutrons together. And at very short distances, like the distances within the nucleus, it has a very strong influence, strong enough to hold protons and neutrons tightly together in the nucleus in spite of the electromagnetic repulsion force between the protons. So an atom's nucleus is held together by the strong force, and electrons are held in the atom with the electromagnetic force. Now, usually there's the same number of protons as electrons in an atom, so their positive and negative charges balance, and the atom is electrically neutral. But if we heat the atoms up and give them a lot of energy, some or all of the orbital electrons could be energetic enough to be able to leave the atom and move through the matter as free electrons. When this happens, the balance between electrical charges is lost and our atom becomes a charged ion. When gas gets ionized like this, we say it's in the fourth state of matter, which is a plasma. Due to the huge gravitational forces in a star, the star heats up and is hot enough to be a plasma, with energy and density so high that we can have atomic nuclei colliding. And it's these collisions that lead to the fusing of nuclei together, nuclear fusion, which releases enormous amounts of energy, millions of times more than combustion releases, which is what makes stars shine. Now, in the majority of stars, most of the fusion that occurs converts hydrogen into helium in one of two ways, either the proton-proton chain or the CNO cycle. The proton-proton chain starts with two protons that are moving with an incredible amount of energy, enough that in spite of the electromagnetic repulsion, they can collide. When we do get a collision between protons, the most common thing to happen is for them to immediately break apart again into two separate protons. But occasionally, one of the protons will convert into a neutron, which is caused by another force called the weak nuclear force. And this gives off a neutrino and a positron in the process. And the positron will collide with a free electron from the plasma, which again gives off a huge amount of energy in the form of gamma rays. The resulting nucleus is called deuterium. The deuterium nucleus then collides with another proton, emitting another gamma ray, releasing a lot of energy. And this results in a helium-3 nucleus. This nucleus can collide with another helium-3 nucleus that was formed by the same process. When this happens, another nucleus is formed, the fusion to helium-4, which emits two protons in the process. And that's how nuclear fusion converts hydrogen into helium in the proton-proton chain. This is the dominant fusion process that happens in less massive stars like our Sun. Now, in more massive stars, we get a different fusion process dominating, called the CNO cycle. This takes a hydrogen nucleus, which is a single proton, and converts it through a series of reactions involving heavier elements, carbon, nitrogen, and oxygen, into a helium-4 ion, which, like the proton-proton chain, releases a lot of energy. While other reactions do take place in stars and form the heavier elements, the vast majority of nuclear reactions in the stars we see are those converting hydrogen into helium. And this, in a nutshell, is what makes stars shine.
Thank you, Natasha. Now I know why stars shine. And thank you for the great astronomy lesson. Okay, so now I invite all the panelists to join me for our Q&A segment.
Hello everyone, we hope you are enjoying the stream. Coming up next is the question and answer segment, but first, some important messages. MBO is a volunteer-run organisation. If you'd like to support us, consider becoming a member, buying some MBO merch, or making a donation. You can find us on social media at these addresses. The live streams are created by a talented and diverse team. You can read the names of those involved below. Now it's time for Q&A.
Hello, everybody. Welcome. Okay, so we have a few questions for tonight. Okay, so our first question for this evening would come from Belinda Lockie, and it's for the ladies on the panel. What first drew your interest in astronomy and space? Who would like to begin?
I can go first. So my love for space started when I was a little girl, and I loved the unknown thought of what's out there and all the possibilities that could occur. And so I've just loved space ever since, and it's such a beautiful environment.
Anybody else would like to share?
Yeah, I get asked that question a lot. And I usually reply, I was born to it. but if you want somebody who influenced me, it was my maternal grandfather, and he would take me out on his front lawn in Mount Morley in Perth, Western Australia, and show me the Southern Cross and show me how to find south using the Southern Cross. And I know I also learnt how to find the saucepan and when I was quite young, and he just fostered a love of science in me all around as well.
Right. Mine was actually Halley's Comet. When I was a little girl, my parents took me outside to show it with my dad's binoculars. So that's what interested me.
I've always been interested in looking up at the night sky and looking at the stars. But one of the things I do remember is, so I'm from England and we watch a lot of Neighbours there. When I was little, Neighbours was on until 6 o'clock, I think, and then I had to do my homework. But Star Trek then came on after that, and I said, if I watch Star Trek, then I won't have to do my homework till 6:30. And actually, through watching it, I became extremely interested, and then started looking at all other aspects of space. So a little bit of an odd one, but whatever works.
Absolutely. Would anyone else like to share before we move on to the next question?
Yes, I'm also a Trekkie. I can completely relate to Natasha. Star Trek got me interested in astronomy, but it was actually looking through a telescope that really blew my mind and really sparked my passion for astronomy. Just to look at the dark patch of sky and then look through a telescope and see the most amazing galaxy. I'm still amazed by it. It doesn't matter how many times I look through a telescope and see that, I'm just still overwhelmed.
Yeah, it is great, isn't it? Okay, moving on to the next question is for Vicky. It's from Candace Candy. Please say a Native American woman was part of astronomy, if any.
Yes, so there have been, especially in the past century. So one of the most famous ones, and we were actually going to talk about it in our presentation, but kind of didn't have enough time. Her name was Mary Golda Ross. So she was basically one of the first scientists to work for NASA and look at interplanetary travel. So she did a lot of maths behind the scenes, and she was basically just starting this whole, I guess, planning and designing process. So I believe that she does have a memorial in a museum. And in 2019, there was also a coin created basically in her honor. So it honors her achievements, and there's plenty of them, and her heritage.
Okay, great. Thank you, Vicky. Now, this next question is for Natasha, and it's from Hammer Jr. They are wondering what a quasar is. Heard them mentioned a couple of times.
Yeah, so a quasar is a really, really bright object. It's one of the most luminous in the universe, but they're actually extremely far away, so they still are quite faint from Earth. But they're essentially thought to be the result of supermassive black holes. So they're very, very massive, i.e. they've got a lot of mass, very, very dense, and they draw in matter, they draw in gas and stars from around them in a swirling accretion disk is what it's called. And the friction between materials in that disk cause them to be very, very bright. They also have these big jets, so because it's spinning, you can get jets from the axis, and they can interact with other things and produce radio waves. So they're billions and billions of kilometers away from us. They're very, very, very far away. So some of the most distant, but also the brightest things in the sky.
Okay, brilliant. Thank you. Okay, so on the questions, Kumquat May is actually referring to the Halley's Comet, and they've said retrograde motion suggests it's not part of a solar formation. Now, Ella, can you put some light onto that, please?
So when I talked about the retrograde motion, it's the body of movement of an object. So for instance, we're talking about Halley's Comet. And so the motion of the retrograde is opposite to the motions of most members of the solar system. So all the planets, they go in one particular motion. However, Halley's Comet actually goes backwards to that. So that's what it's referred to as retrograde. It's doing the opposite, being special.
Fantastic. Thank you for that explanation, Ella. Now, this next question is from Bron Anderson, and they have asked, what is the biggest telescope ever built? Jackie, I think you can explain this one.
Right. Okay, I'm gonna ask this and answer this in a couple of ways. So the biggest refractor ever built. So this is the one with the lens at the front. Is the 40-inch Yerkes refractor. So that's in, I think it's Wisconsin. It's just north of Chicago, about 100 miles. And the 40 inches. I forget how much that is in metric. That is the actual physical limit you can do with a lens, because then it sags under its own weight and it won't work properly. So there is a physical limit to telescopes with a lens at the front. So you really need to go to mirrors. So the biggest one in the world at the moment, I think, is still the Keck telescope. So there's lots of solid 8-meter telescopes around. Some of them working in unison, like there's a whole lot in Chile. So the Keck telescope is a series of hexagonal mirrors altogether, and they're 10 meters across. The Vera Rubin telescope observatory, that's going to be the 30-meter one. I think that's the next step up. And in comparison, Hubble is only 2.5 meters across. And its advantage is it's above the atmosphere, and it doesn't have all that horrible wavy moving about water-filled atmosphere. That's why it does so good. But some of the telescopes on Earth can actually outdo Hubble these days. So the 10-meter Keck, I think, still outdoes everything, unless somebody's going to disagree with me in the comments. But I think Keck's still the winner at the present time.
Fabulous. Thank you, Jackie. Okay, the next question is for you, Jamie. Sanyana Dizzy wants to know what's a good spot to see the Milky Way?
Well, a good spot to see the Milky Way is basically anywhere where you've got little to no light pollution. And it's better to wait until the sun has gone down completely, and it's been gone for a couple of hours is probably the best time to have a look for it, because then that way you haven't got any light pollution coming from the sun either. And somewhere like MBO is a great place to have a look at it, because we're relatively remote from towns and cities. Like Emerald is probably one of our closest ones, or Cockatoo and Pakenham. We can still see the lights from there, but there's not as much interference as what the lights would be if you were actually in one of those places. So basically just anywhere where you've got little light pollution and the sun's been down for a couple of hours is a good spot to see it.
Great, thank you for that. Now, my next question is not mine, but the next question is from Sam Rawson, and this one's for you, Gail. Sam would like to know, where did you get the phone attachment from in regards to your telescope? I would presume.
Good question, but I actually don't use a phone attachment. I do have one. However, I honestly just use my hand. You have to be really, really steady, and I'm sure a phone attachment works great and all for it. And like I said, I do have one, but I prefer just to be really steady, and I take it with my hand. I don't actually use a phone attachment, but I definitely know you can buy them, and I have one. But yeah, it's what you prefer.
Great. And while I've got you, Fiona Taylor has also asked, what is the name of the telescope that you use again?
So the brand is a Saxon. It's a pretty popular brand, and it's a 1149 EQ. Thanks, Adam. Yeah, so that's the exact telescope that I use. And like I said, it's perfect for beginners and an introductory to astronomy.
Great, thank you. Okay, next question is for you, Ella, and Muget Gil wants to know what powers a comet.
So that is a great question. So a comet, most of the time, gets powered by the sun if it's in orbit of our solar system. So the sun provides heat that drives some of the material out from the nucleus of the comet. So that's the head of the comet, and that some of that material gets driven into its coma. So that's just behind, and that spreads into the tail. So most of that material gets pushed through the tail, and that provides enough pressure to keep the comet into that motion of the orbit. So that's an amazing question. Thank you.
Thank you so much. Okay, now Luke, who is 9 years old, has asked a couple of questions, which I'm going to direct towards you, Jackie. Okay, his questions are, why have there been so many men up to space compared to women? No, sorry, he's asked the same question twice.
Yeah.
My apologies.
Yeah, no, that's okay. Because the men who were running the show back in the 1960s thought that women were really fragile and couldn't handle the rigors of being in space, because space is actually a really, really dangerous environment. And so let's be honest here. Space is dangerous. It's dangerous being in space. There's a lot of dangerous stuff out there. But the men who were running the show and making the selection of who went into space had this idea that the women were really delicate and couldn't handle it. But if you actually go back and look at the records, because when they chose the Mercury astronauts, they were also testing women at the same time. The women actually tested better than the men. But they decided, oh, no, we just can't send any women. That's just not the done thing in our society at the time. We're going to ignore those physical results and just send some men up. So it's largely a society-driven idea that women can't take things. And that's why it's taken so long to change, and that's why more men get sent up than women. If you look at how many get sent up in the last 10 years, you'll probably find it's 50-50. But in the decades prior to that, it was definitely more men than women, because there was a bias towards men being sent up.
Okay, so there is a question for you, Vicky, and it's from Alilia. Sorry, my apologies if I pronounced it wrong. It is, how far away is the sun from the Earth? Vicky's not here. She left us. Okay.
I'm muted. I'm really sorry.
No, that's okay. I've done it before too, Vicky. It's fine.
So the sun is very far away from the Earth. So if the exact distance would probably be very difficult to measure, but it is approximately 148 million kilometers.
Wow, that is a long way from the Earth. Okay, Ella, we have a question for you. Emma Willis would like to know, where do comets come from?
So comets come from two places. So the short period comets like Halley originate from the Kuiper belt. Hopefully I pronounced that right, which is a scattered disk of rocks and dusty material just beyond the orbit of Neptune. However, the longer period comets actually originate from a place called the Oort cloud. So that is a huge cloud way past Neptune, and it's full of icy materials, and so the longer term comets come from there. But since the universe has originated, comets can come from all over the place because of how diverse the universe and how big it is.
Great. And while I've got you, just another question from Brianna, who is aged 9. She would like to know, how big is Halley's Comet?
So Halley's Comet is a peanut shape. So just imagine very big peanut traveling through space. And so it is about 16 kilometers long. So that's from about Belgrave to Rowville. It is 8 kilometers wide. So that's from Rowville area to Wantirna. And then it's also 8 kilometers in height as well. So as long as it doesn't come towards Earth, we'll be all right. So thank you for that question.
Okay, excellent. Now, just a couple more questions before we finish off the night. This one's for you, Natasha. Saxon, who's age 7, has asked, do planets go around the sun clockwise or anti-clockwise, and why?
So if we're looking from above the north pole of the sun, then all the planets rotate around counterclockwise, anti-clockwise. And that basically is because of the initial conditions when the solar system was formed. It could have just as easily have ended up being everything going clockwise, but those conditions led to everything going counterclockwise. And in fact, almost all of the planets rotate on their own axes counterclockwise as well. There are a couple of anomalies. Uranus is almost entirely it's sort of on a slant, and Venus actually rotates about its axis very slowly clockwise, but that's just thought to be the result of events such as collisions.
Okay, fabulous. And for the last question tonight is from Olivia, and she has asked, and this one's for you, Jackie, who was the first lady to go into space?
Well, she was a Russian. Her name's Valentina Tereshkova. I think I've got that right. She's still alive today. She's still around. She was sent up, and as she was orbiting around, she realized that the program in the simple computer in the capsule she was in was wrong. And if she didn't get it changed, she would actually skip off the atmosphere and not return to Earth. So she was smart enough to recognize that something was wrong, and she had to ask for the correct program to be sent up so that she could return to Earth safely. So yeah, thanks for the technicians and engineers that didn't bother to check the program to make sure she could get down safely, and she had to make sure that she got herself back down safely. Good one, guys. There we go.
Thank you so much for that. Now, we've come to the point in the Q&A where I need to announce the winner. So we've decided that we're going to have 2 winners tonight. The first the prize goes to is to Belinda Lockie for her question about asking us all about what first drew our interest in astronomy astronomy in space, and also to just that last question there that Olivia asked. So if you could you please send your details to get your Planisphere sent out to you on either Facebook Messenger, for the MBO Facebook Messenger, or using the email below so that we can send those prizes out to you as soon as possible. Okay, and on that note, the time has come to conclude tonight's show. Thank you all for joining us, and we all hope that you have enjoyed our tribute segment to women and girls in science. If you have, please join us again for future shows or rewatch any of our past segments on Facebook and YouTube. And also, don't forget that you can join up as a member at any time at the website, which is going to come up right now down below. Good night.